Welcome back. In the last video, we followed medical gas from production to storage. Now we're at the bedside where you may stand in front of a cylinder and prepare to connect it for a patient. Keep this question in mind. There's a cylinder in the room with a green shoulder and your patient needs oxygen. Is that cylinder safe to connect? Let's get into the lecture. Before we answer, look at the cylinder's size. An e-cylinder is commonly used as a portable source for transport or emergency use. It can travel with the patient on an appropriate cart or holder. Now, H and K cylinders are much larger. They're generally used as larger stationary or reserve supplies rather than for routine patient transport. So size can suggest the cylinder's role, but it does not identify the gas inside. So how do you verify the cylinder? Use several clues and always begin with a readable product label. The label supplied by the gas supplier identifies the gas in words, and this is your primary source for identifying the contents. Then use the other clues to support what the label tells you. The permanent marking stamped into the shoulder describe the cylinder itself. They may include the DOT specifications, the service pressure, the serial or ownership information, and the dates of the original hydrostatic test and later retesting. The markings tell you about the cylinder's construction and service history. They do not identify the gas currently inside. You can also consider shoulder color, cylinder size, and gas specific connection. Gauge pressure can help estimate usable supply in a non-liquefied compressed gas cylinder, such as oxygen. Now return to the green shouldered cylinder from our opening. If the product label is missing or unreadable, it is not safe to select for oxygen therapy. Color is only a supporting clue. Remove the cylinder from service and follow facility procedure. Okay, so next look at the top of the cylinder. The cylinder valve contains the gas by sealing the outlet until the supply is intentionally open. The pressure relief mechanism has different safety role. It responds if pressure or temperature reaches a dangerous level. So for example, if heat rises the pressure inside a cylinder, as we talked about in week 1. A relief mechanism provides a controlled way for pressure to escape before the cylinder fails. So we never tamper with, obstruct, or attempt to alter a pressure relief device. That's just dangerous. So let's organize the connection system by where they're used. No single connection system serves every part of medical gas delivery. So you have small cylinders that use the PIS, the pin index safety system. It's a pin and hole pattern that helps prevent a regulator from one gas from being attached to a smaller cylinder containing another gas. A large high pressure cylinder uses a gas specific CGA outlet and matching regulator, not the DIS system. Okay, so after the regulator has reduced the pressure, you're now on the low pressure side. And this is where you may find the DIS or a gas specific quick connection system at a station outlets and equipment connection. These systems share one safety idea. Incompatible parts should not connect. If a connection will not fit, treat that mismatch as a warning. Stop and verify the gas, cylinder, device, and the connection. Never force a connection or improvise an adapter. So let's look more closely now at the PIS. On a small cylinder valve, the yoke connection has a specific arrangement of holes, and the regulator yoke has matching pins. The regulator can seat correctly only when those pins align with the cylinder's hole. Each gas uses a specific pattern. So for oxygen, the pin positions are 2 and 5. A regulator with a different pin pattern should not seat on that oxygen cylinder. Now consider the question on the slide. You have a cylinder and an oxygen regulator, but the regulator will not seat correctly. What should you do? So I would stop, do not force it, or try to create a workaround. The mismatch is useful information, and that cylinder may be wrong. The regulator may be wrong, or the pin's yoke or valve connection may even be damaged. Back up and verify the product label, the regulator, the required connection, and the condition of the components. The safety system is doing its job by making you stop and verify. All right, so now we'll move on to the low pressure side of the system. The DIS, that stands for a diameter index safety system. It is a gas specific threaded connection used with a low pressure outlets and equipment connections. The diameter and the threads are designed so that the correct gas fitting matches the correct connection. So quick connect systems are also gas specific, but they use a keyed or shaped connection instead of a threaded one. They're common at station outlets and their designs can vary. So use a connection intended for that outlet and that gas. So a fitting that appears close enough is not safe enough. So confirm that the outlet, gas, and equipment connection match. Never substitute, improvise, or any of that to an adapter. So let's separate two terms that are often mixed up. So you have regulator and flow meter, and a lot of you probably have already seen this in the lab. But a full oxygen cylinder may hold gas at approximately 2,200 pounds per square inch. That's a lot. And patient delivery equipment is designed to receive reduced working pressure, not full cylinder pressure. So the regulator reduces that high cylinder pressure to a lower, more usable pressure. But the flow meter has a different job. It sets or indicates the rate of gas flow, usually in liters per minute. One device changes pressure, the other sets or indicates flow. Pressure and flow are related, but they are not the same, and their terms are not interchangeable. We'll work with the equipment in more detail during lab and later in this course. All right, so let's bring the full safety check together. The product label identifies the gas, other clues supporting that identification, then the cylinder, connection, regulator, and low pressure outlet or equipment connection must all agree before use. So in the next video, we will look at how correctly identified cylinders are stored, transported, and monitored safely.